Hello everyone, my name is Nicoya, and this is the Korg SQ-1. This is a CV and technically MIDI and little bit sequencer, and to the surprise of probably absolutely no one, since it's on my bench, it is not working. So, this is a bit of a mystery, because there's not actually that much that can go wrong in one of these. So let's open this up and have a look at what's inside. Okay, so we're not seeing all that much just yet, just the bottom side of the board, and everything looks good so far, so let's keep going. Okay, so we're into the actual circuit board here, and we can see that something is definitely amiss here. We have the crystal over here on the side, and it is upside down and hooked on with some bodge wires. So that's not how it's supposed to be. The good news is that it's actually hooked up to the right place, but the bad news, once we get this under the microscope, is that whoever did this bodge completely screwed it up. All right, as we can see, we've got quite the bodge going on here. This is the main CPU right here. I can't tell what that is right now, but it is the microcontroller that runs everything. And over here we have the crystal, which is supposed to be the oscillator for it. And as I said, it is technically wired to the right pins, but unfortunately, if we push this aside a little bit, I can see what I'm doing here. We can see that when they bodged things together, they soldered onto the load capacitors, which is good, but they also managed to bridge to this resistor here on the side, which is connected to the ground plane. And so that means that this side of the crystal is actually completely grounded out, and so the crystal can't oscillate, and this microcontroller can't start up. So that's pretty much going to be why our sequencer isn't working. So the simple answer here is that we are going to desolder these bodge wires from here. We're going to rebuild the traces under here. Let me see, I'm going to lift this up. So as you can see, the traces were ripped off the board here, and they also glued this down with, I think, some silicone. So I'm going to have to scrape that off, which is just super. But yeah, I'm going to try to rebuild these pads a little bit, I think, so we can actually stick this crystal down in the correct orientation, but we'll see how well that works, I guess. Anyway, I first need to start with actually just pulling this crystal out of here. So let me grab a soldering iron and see if we can do that. I think I might need to reorient this a little bit, though. Okay, so the crystal is off now, and I'm going to solder wick away that giant bridge between C22 and R13 there. That's looking a little better. Check the conductivity, make sure we're not shorted out anymore. All right, so this is still connected, and that is not good. So now I need to build out a trace from here to here and get rid of this glue. And then from here to here, hopefully without shorting out that pad there, but I have some solder mask I can paint over that, which I think I'm going to use. So I am going to do a bunch of scraping now. So I'll meet you back here in a minute once all this gunk is cleaned up. All right, did a bit more work here and cleaned up all the glue off of there. And obviously I've also gone ahead and started rebuilding the pads here. So I bent up some bus wire into sort of a pinched U shape, and led it over here towards the load capacitors. There was enough of a trace under here that this one's actually soldered down to it, but this trace is actually obliterated, so I'm going to have to bridge over to here manually, and I'll probably do that after I solder the crystal onto here, just so that whatever I do here doesn't melt off when I solder this. So next up, I'm going to put some solder on here to match the blob on here, and then I'm going to get the crystal in there. So, all right, not going to lie, that was pretty challenging to get all soldered together. I didn't quite realize how close the crystal would be sitting to the load capacitors when I made that little pad that it was sitting on, and so getting in here was a bit of a challenge. But if we check the conductivity, good on that side, and we check the conductivity here. I can poke that and then get into here. We're good there, and we are not shorted to ground. We'll poke this side here again, and ground should be, these kind of look like ground here. We got nothing, so we're good. So now all that remains is to put this back together and see if it's alive. So let's do that. Uh-oh, I think a screw is missing. I'm going to check and see if that screw is missing in the first place. I'll be right back. Okay, good news, sort of. This screw was actually missing from the start, so it's not my fault that it's gone. Don't blame me, blame the last guy. Anyways, let's get this back together. Okay, moment of truth. Let's see if the smoke comes out. Well, there we go. I think that is fixed. I thought the thing would go along here, but I'm not sure. Yes? No? Is that supposed to go? Let me look up at the manual and see what I'm doing wrong. Okay, I think I found the problem. This is the sink in jack right here, and if we look at the sync out jack, these are jacks with a switch in them. So if we look at the tip and here, we see that's closed. We'll look the next one over. Closed, it's closed. But the sync in jack is open, which means that the unit thinks that there's a plug plugged into here and it's waiting for an external sync. And so I think if I squirt some contact cleaner in there, and if I grab a jack and jack in and out of there a few times, and yes, it is going to look exactly that lewd, then I think that should fix it, hopefully. So let me try that. Ooh, that jack feels really loose. That's what she said. Let's see if that did the trick. The answer is no. Interesting. Tell you what, I'm going to swap the in and out jacks. I think that will help us here, because the out jack is working fine. And I don't think it matters if these ones, if the output does not have the switch on it. It should only need to detect the input. So I'm going to heat up my desoldering iron, and I'm going to swap these two jacks. All right, that swap wasn't actually too bad. So I now have the dodgy connector on the sync out. So we check the continuity here, we get nothing. But on sync in, we should now be able to detect that there is no nothing inserted into there. So we'll go ahead and power this back on and see if our gate advances, or our steps advance. So power on, we still power on. Okay, that's doing more what I thought it should do. Yep. Okay, that's working now, I think. So let us check the CV and gate out, and I'm going to do that with my MG1 as soon as I finish putting the screws in here. So be right back. All right, here we go. Got my MG1 out. Now, for those of you who aren't familiar with the MG1, one of the peculiarities is that although it does have a CV and trigger / gate / whatever on the back, the pitch input actually works at the usual sort of 1 volt per octave thing, but the trigger is treated as more of a dry contact, and so you're supposed to close a circuit between the tip and ring of that connection instead of supplying like 12 volts or 10 volts or whatever the usual gate voltage is. And so what I'm going to do is I'm going to put a little mod in here that a lot of people have probably done before, which is to add a transistor so that you can just supply like your usual gate voltage. It will switch that transistor on. That transistor will close the contact between what used to be the tip and the ring, and then that will give you your proper gate that the synth is expecting. Okay, so this is the circuit we're going to be making here. This is our input jack here. We got the ring and the tip. Usually the tip would be tied to the gate here. And now the voltage on the gate with the circuit that is inside the MG1 can vary between plus 12 volts when there's no key pressed to negative 1 volts when a key is pressed. It will activate sufficiently if you put 0 volts on here, and so since the ring is on ground, you just connect the two, that triggers your gate, and you're good to go. But the negative 1 does mean that if we just build this circuit with a input resistor here and our NPN transistor, then when that goes to negative 1 volts, we could have like a slight backfeeding through the collector of this transistor. And so since I have a bucket full of 58 volt Zener diodes, for some reason, I have no idea why anyone would want a 58 volt Zener diode, but since I have these and they work as regular diodes, I'm going to put a diode in. So yeah, I'm going to make that executive decision. You obviously don't have to do that. 1 volt through 100k ohms is not going to screw up whatever's on the other side of here. But I feel like doing this, and also I'm going to need to jumper a few pins over on this piece of perf board here. So let me get all the components in here and we'll solder it up and we'll go from there. Alright, so we got our input on the center pin here. Our output, our collector is on the this third pin, and then on the back side here, that's going to be connecting up to our ground / our ring. So I'm going to do a few quick checks on this, and then we'll cut this off and put it in the synth. And I just realized I was super zoomed out for that, so here's the close-up of that circuit. And I hope I remember the pinout of this transistor correctly, because if I didn't, I'm going to be annoyed. Okay, so inside the synthesizer, wow, I can really say that, we have our trigger wire and our ground wire there. And so I just realized I need to put another fly lead on this so I can actually get the ground on there. So excuse me one moment. So the ground we're going to leave soldered in place, and we're just going to solder this onto it. The trigger we have to pull off and put onto there. So let's see how much they wrap this around here. Back in the 80s. Well, the answer is not too much. Wasn't too bad. Now I hook that onto there. And I'm not going to go crazy with the wraps because, you know, someone in the future might want to remove this. Who knows? Then we need the ground on there. All right, that's on there pretty good. I'm going to tape this up with some Kapton, and we will give it a try. Okay, the important first test, does it still work? Pretty good. Let's hook up the sequencer and see what it does. Well, I don't know about you guys, but that sounds like victory to me. So, my mod worked on the MG1, the CV outs are clearly working on the SQ-1, and I hope you enjoyed that video, and I will see you on the next one.